some problems remain unsolved even after compensating for problems during machining. The most common is machining errors concentrated in the line angles on the inside of the crown. This problem can be solved by design. The left side is uniformly 50 micrometers, the center is 80 micrometers, and the right side was experimented with a cement gap of 80 micrometers for the line angles only and 50 micrometers for the rest. I designed and machined each of the printed abutments. I used resin cement. After bonding, they were scanned and compared to the design file. The uniform 50 micrometers result on the left was found to be under-integrated and protruding towards the occlusal surface. The rest all appeared to be recessed well. I cut it to see the actual cement space. The uniform 50 micrometers group on the left showed a thicker occlusal cement space due to less crown recession of hanging line angles. The middle uniform 80 micrometer group showed a thicker cement gap compared to the right selective cement gap group. The right selective cement gap group showed the most uniform cement space. As a result, it's useful to impose selective cement gaps in the design to achieve uniform cement space. These are the conclusions from today's lesson. Fitting a machined crown to a model will not solve the problem. You need to use model-less verification to find and fix the cause. Choose and purchase equipment that is well calibrated and maintained. Line angle machining errors that are not solved by machining errors require the application of selective cement gaps.